Now we're going to work on finding the domain of a function where the function in question is piecewise defined. So here we have f of x defined to be 3x plus 1 whenever x is greater than or equal to 0, and is x squared whenever x is less than minus 1. Okay? So before doing these types of examples, I highly recommend you get practice just plugging stuff into piecewise functions to know what happens. That is, like, what would happen if I plugged in x is equal to 1? Plug in 1, I get, well, I'm going to go here because 1 is bigger than or equal to 0, and I plug 1 into this guy, so I would get 4. So if you're familiar and comfortable with doing that, then this example will be for you. We got to find the domain of this piecewise defined function. So we're going to use what I like to call the shade and erase method. So we're going to first start by looking at our intervals on the right-hand side of the piecewise defined function, and we're going to shade in those intervals. So if I have greater than or equal to 0, I'm going to put a square bracket here with a pencil. It's going to be one of the very few times I use a pencil. And then I'm going to shade all to the right, because we're looking at all x values that are greater than or equal to, that's why I use the square bracket, greater than or equal to 0. So I shade in everything to the right. So greater than, that's the key there. All right, looking at the second part, x is strictly less than minus 1. So I'm going to put a round bracket at minus 1, because 1 is not included in that. Sorry, minus 1 is not included in that. And x is less than minus 1. So we shade everything to the left. So these are all potential places where our function could be defined. All right, we're looking for, again, the domain of a function is the set of all x values that I could plug in here. So what's shaded so far is is the set of x values that I could potentially plug in. So now that I've shaded everything, I'm going to go back up to my first case here where x is greater than or equal to 0, i.e. this shaded region. I'm going to look at my function and see, is there any case of division by 0 inside this interval? If the answer is no, we don't erase anything. Is there any chance for square roots of negative numbers here? No. In fact, 3x plus 1 is defined for all possible x values, so it's certainly defined when x is greater than or equal to 0. So this 3x plus 1 is defined everywhere on this interval. So our domain is going to consist at least of the square brackets to infinity. So we'll write that in a few minutes here. Now let's take a look at the second part. I'm looking at x squared in this interval. Is there a chance that I'm going to have a square root of a negative or division by 0 here inside this interval? The answer is, of course, no, because x squared is defined for all x values, period. Like if it weren't even in parts, like if I were just looking at x squared, it's defined everywhere. So it's certainly defined when x is less than minus 1. So this part is defined everywhere in here. So my domain, since I have no restriction inside this domain, is going to be as follows. Domain of f is going to be equal to minus infinity, because it starts all the way over here, shaded forever, to where does it stop? Minus 1. And I put a round bracket there because there's a round bracket here. Union, meaning including this guy over here. Square brackets starting at 0 and then going to infinity. That's the domain. You just basically include all your shaded regions in the listing here. If there's a break, like there is from minus 1 to 0, then there's going to be a union symbol. All right, so hopefully that makes sense. In the next several examples, we're going to look at cases where this might have division by 0, or this might have square roots of negative numbers. So we will actually have to erase parts of our shaded regions in order to find the domain. So if this video was helpful, please like and subscribe. And if you want to see more videos like it, please head over to projectgradered.com if you're not watching from there already. I'll see you in the next example.